Hello everyone. In this lecture we will be designing an NFA and we will convert it to its equivalent DFA. Alright, so here is the question we have. Design an NFA for a language that accepts all strings over 0, 1 in which the second last symbol is always 1. Then convert it to its equivalent DFA. So what we have to do is we have to design an NFA for a language that accepts all strings in which the second last symbol is always 1. So for example, the strings that it should accept are strings like 1010. See, second last symbol is 1, or let's say 110, or let's say 1101010. See, the second last symbols are always 1. These kind of strings are the strings that should be accepted by our NFA. So first we will design the NFA and then we will convert it to its equivalent DFA. So let's see how we can do this. So first of all, I will be designing the NFA. So we will draw the state transition diagram first. First I'll start with my starting state, which I will call state A, and in A, whatever input I get, whether it is 0 or 1, let it stay in A, because this is the first state and I don't care what happens in the beginning. I am concerned about the second last symbol. So in the beginning, whether it is 0 or 1, let it stay in state A, and state A will go to the next state, that is state B, on getting the input as 1. That means now I assume that this is going to be my second last symbol. So if this is going to be my second last symbol, I send it to the next state B. So I reach the second state B, and then state B goes to the next state, state C, that is the final state on getting the next input. So here, as I told you, I'm only concerned about what are my second last symbols. So second last symbol I already got as 1. So the last symbol, I don't care whatever it is, let it be 0 or 1, it goes to state C. So now my NFA is complete. So I don't have to mention what happens in C because this is an NFA. B and A we have completed. Now we'll draw the state transition table for this. So in this table, what will be the elements I have? I will have my inputs, which are 0 and 1, and then I'll have my states. A is the starting state, so let me give this arrow, then B, and then C. C is the final state, so I'll give a circle around C. Now let's fill up this table. A on getting input 0, where does it go? A on getting input 0, it stays in A itself. And A on getting input 1, where does it go? On getting input 1, A goes to A itself, and also it goes to B. So it goes to two states, namely A and B. And let's come to state B. B on getting input 0, where does it go? B on getting input 0, it goes to C. And B on getting input 1, where does it go? B on getting input 1, it goes to C. Okay, and coming to state C. C on getting input 0, where does it go? It goes nowhere. And C on getting input 1, where does it go? It again goes nowhere. So we mentioned as phi. That means it does not go anywhere. Okay, so now we have completed the state transition table for the NFA. Now we will try to design its equivalent DFA. For that, I will convert the state transition table to the equivalent transition table for DFA. So let me draw the table over here. So in this table we will be doing for DFA. So my inputs are 0 and 1, and what will be my state? I will first start with the starting state, which is state A. A is my starting state, and let's see, where does A go? A on getting input 0, where does it go? It goes to A itself. Alright. And A on getting input 1, where does it go? On getting input 1, A goes to two states, A and B. But in NFA, two states are possible, but in DFA, two states are not possible. We can set it to only one state. So we will combine these two states, A, B, and make it a single state, which I will call state AB. This is a single state, AB. Alright. Now looking at this row, we have to decide what should be the next state that we should decide. So here we see that the only states reachable from this row are A and AB. So I've already written for A. The next thing is AB. So we will talk about state AB. And in order to see where does AB go and getting input 0 or 1, what should I do? I should go to this table and I should look at both A and B, and I should perform the union operation of A and B on getting particular inputs. So AB on getting input 0, I should perform the union operation of this A and B on getting input 0. So union operation of A and this C, it will be AC. AC, which is also a single state, and then on getting input 1, union operation of A, B and C. So it is A, B, C. A, B, C. Okay. Now coming to this row, let us check what are the states reachable from here. AC and ABC. So let us write about state AC first. AC. So AC on getting input 0, where does it go? I have to come to this table and perform the union operations of A and C. So on getting input 0, the union operation of A and phi, which is A itself. Okay. And on getting input 1, union operation of this A, B and phi. So it is A, B. Okay. Now we have finished. And from here we see that the next states reachable are A and AB. So I've already mentioned for A and AB. So what was left from this one? ABC was left. So let us discuss about ABC. ABC. Now in order to check for ABC, I have to perform union operations of this A, B and C in this table. So on getting input 0, union of A, C and phi, which will be AC. And on getting input 1, it will be union operation of A, B, C and phi, that will be ABC. ABC. Okay, so now we have made the transition table, but we did not mention which is the final state. So in this table, C was the final state. So in this table, whichever states that contains C will be the final state. So we see that AC contains C and ABC also contains C. So these two will be my final states, AC and ABC. Okay, now we have finished the transition table. Now let's try to draw the transition diagram. So we'll start with this starting state, which is state A. I start with my starting state A, and A on getting input 0, it stays in A itself. On getting input 0, A stays in A itself, and on getting input 1, it goes to AB. So it will go to AB. When does it go to AB? On getting input 1. Okay, so we have finished for state A. Now let's come to AB. AB on getting input 0, where does it go? It goes to state AC. So let me make state AC over here, and let us remember that AC is a final state. So I have to put 2 circles around this AC. Okay, and when does AB go to AC? AB goes to AC on getting input 0. Alright. Now AB on getting input 1, where does it go? It goes to state ABC. So here I'll make another state called ABC. And ABC also is a final state. So I have to put 2 circles around this ABC. So I put 2 circles around this ABC. So AB goes to ABC on getting input 1. Alright, this one. Now let's check for state AC. AC on getting input 0, it goes to state A. So AC on getting input 0 will go to state A. And AC on getting input 1, where does it go? It goes to AB. So AC on getting input 1, it goes to AB. And now finished AC. Now let's come to state ABC. ABC on getting input 0, it goes to AC. ABC goes to AC on getting input 0. And on getting input 1, where does it go? It goes to ABC itself. So ABC stays in ABC itself on getting input 1. Okay, so now we have finished the transition diagram for the DFA. So we have designed the DFA successfully. Now let us just check if these strings will be accepted by this DFA. So we know that it should be the strings that ends with 1 as the second last symbol. So here 1 0 1 0, 1 0 1 0. So it comes to AC. That means AC is a final state, it is accepted. So this is accepted. Now let's check for this one. 1 1 0, 1 1 0, right? So it comes to AC. So that is also accepted because this is the final state. And let's check this. 1 1 0 1 0 1 0, 1 1 0 1 0 1 0 comes to AC, which is the final state. So this is also accepted. So we see that all these three are accepted because it ends with 1 as the second last symbol. So all strings that has 1 as the second last symbol are accepted by this NFA and DFA. So if you were to design the DFA directly without having this NFA, you would have to think so much and do a lot of designing. But if you design the NFA first, because designing NFA is very simple, so if you design the NFA first, it is very easy to convert it back to the DFA. So this is how you can design the NFA and convert it back to the DFA.